Tonight, we're not planting seeds in soil, we're planting them in orbit. The art of hydroponics has left the greenhouse, it has left the desert, it has left the Arctic, and now, it's knocking on the hull of a spacecraft. Hydroponics and its cousin, aeroponics, are no longer just farming techniques. They are survival systems. When space agencies began planning long-duration missions, they faced a simple, but huge, problem. Astronauts can't carry years of fresh food. Stored meals degrade, vitamins break down, and honestly, morale plummets. So a question started echoing in laboratories around the world. Can we grow food beyond Earth? NASA began studying hydroponic systems decades ago, not as a cool novelty, but as a pure necessity. Up on the International Space Station, astronauts have already grown lettuce in controlled plant growth chambers. There's no soil, no gravity pulling roots downward, just a nutrient-rich solution, light, and some very careful engineering. See, in microgravity, water behaves strangely. It forms floating spheres, it clings to surfaces, it refuses to drain the way it does on Earth. You can't just pour water on some dirt and expect gravity to do the work. Hydroponics solves that. By delivering nutrients directly to the roots in a contained system, water can be managed even when gravity's barely there. Specialized units like the veggie system and the advanced plant habitat were designed to control everything. The light spectrum, humidity, airflow, and nutrient delivery. Every single variable matters. Light has to mimic the sun. Air must circulate so roots can breathe. Carbon dioxide must be balanced. The temperature has to stay perfectly stable. Plants grown in orbit are monitored constantly. Their leaves are photographed, their growth rates measured, their nutritional value tested. Why all the fuss? Because fresh vegetables are so much more than calories. They provide crucial vitamin C. They provide antioxidants, and maybe most importantly, they provide psychological comfort. Imagine living in a metal cylinder for months on end. There's no breeze, no smell of soil, no green horizon. Now, imagine harvesting a fresh leaf of lettuce that you grew yourself. That changes everything. NASA studies show that caring for plants reduces stress in confined crews. It restores a sense of connection to Earth. Hydroponics becomes emotional infrastructure. But low Earth orbit is just the beginning. When we talk about missions to Mars, the timeline stretches dramatically. Resupplying from Earth becomes completely unrealistic. Food must be grown on, but Martian soil is toxic to humans. It's full of perchlorates and lacks the organic structure plants need. So with hydroponics, soil quality becomes irrelevant. Systems can be enclosed inside pressurized habitats. Water can be recycled. Nutrients carefully rationed, and light provided by energy-efficient LED, tuned to the perfect red and blue spectrums for photosynthesis. A future Mars salad. It's entirely possible. Researchers are even testing where roots hang in the air and get a nutrient mist. Aeroponics uses even less water. Fine droplets deliver oxygen and nutrients at the same time. Less mass, less water weight, more efficiency. And in space travel, every single kilogram matters. Hydroponics reduces the amount of cargo we have to launch. Seeds weigh almost nothing. Water can be recycled from the crew's own waste systems. The carbon dioxide exhaled by astronauts feeds the plants, and the oxygen released by the plants feeds the astronauts. It becomes a Looper-closed, ecological life support system. Humans breathe out CO2, plants breathe it in. Plants release oxygen, humans breathe it in. Water cycles, nutrient cycle, air cycles. Space farming isn't just agriculture, it's ecosystem engineering. And the technology doesn't just stay in space. The advancements we make for off-world farming trickle back to Earth. We get more efficient LEDs, better water recycling methods, and advanced nutrient monitoring systems. This tech helps urban farms, desert agriculture, and even disaster relief effort. The dream of a Mars greenhouse might just help stabilize food systems right here on Earth. Beyond just food, plants in space help scientists study fundamental biology. How do roots know which way is down without gravity? How do cells adapt? The answers deepen our understanding of life itself. So, the image of an astronaut harvesting a tiny crop in orbit might seem symbolic, but that symbol is a rehearsal for something much bigger. The first leaf grown in space is a practice run for becoming a multiplanetary species. Future Mars habitats might glow softly at night, illuminated by rows of green, living plants. Not fields under an open sky, but ecosystems under engineered domes. It's a new chapter in the story of agriculture, one that extends beyond our atmosphere. One day, When humans step onto Mars for good, they'll unpack not just tools and habitats, they will unpack seeds. They will assemble hydroponic modules, and they will watch the first green leaves unfurl against a red horizon. When that first harvest happens, it won't just be a meal, it will be proof. Proof that life, carefully engineered and sustained, can travel with us. Proof that we don't need soil to grow. Wherever humans go, our gardens can follow. Thanks for watching. If you're fascinated by the future of space exploration and technology, be sure to subscribe for more videos.